All right. So in this problem, this is the only problem that you have where when you sum up your torques, they don't add up to zero. There actually is going to be, we want this arm to actually move forward. So we need an imbalanced torque. We need a torque that doesn't add up to zero. So if you look at this picture, the only force acting on this is the muscle. There's no other force up here. Yes, you are applying a force to the dart, but there's no other force on the arm. So this is the only force that's going to cause this arm to rotate forward. And to begin the problem, what we want, like our equation that we're going to be using is that torque equals I alpha. I mean, that's, whenever we're doing these, torque equals I alpha. The thing is that in all of the problems, I alpha was zero. So we have torque equals I alpha, and we also have that torque equals F perpendicular times L. So what I'm going to do to solve this problem is I'm going to set them equal to each other. So I'm going to say that F perpendicular times L equals I alpha. And once I know, and in my problem, the unknown in the problem, if you read it, the unknown is the force. Determine the magnitude of the force M needed to give the dart a tangential speed of that. Well, that's the force perpendicular because our picture is going to, I mean, I can put the stuff right on the picture. So let me do that. My arm, my forearm is what's moving. So from here to there, that's my forearm. And I've got only one force, and that is this right here. That's the muscle. And my pivot point is right there. So if I look at the picture here, what I have is I have the muscle is the force perpendicular. The L is the 0.025 meters from where the muscle is applied to the pivot point. So I know that, and I know that. I also know I, because if you read the problem, it says the forearm has a moment of inertia of 0.065 kilogram meters squared. So that's what I'm looking for. I know that, and I have enough information to get that. So all I need to do is solve that, and then I'll be able to get the muscle. So it says that the tangential speed, the dart has a tangential speed of 5 meters per second in 0.10 seconds starting from rest. So I basically have to do like doing a straight line motion problem to get A. Because if I can get A, then I can get alpha. So that's what I'm going to do first. So I'm going to have, if I list my facts, I'm going to have that my original velocity is 0 meters per second. I'm going to have that the time is 0.10 seconds. And the final velocity is 5 meters per second. And with those numbers, I can solve for the acceleration of the arm, the tangential acceleration. So that's the unknown. So it's like I'm doing a straight line motion problem here. When I'm solving for tangential speed, I am using V's, S's, A's, and T's. I'm not using alphas and thetas and omegas. So I'm going to use these to solve for A. So my step 2 is to pick the correct equation, which would be VF equals VO plus AT. Step 3, well, VO is 0, so I can cancel that out. If I solve for A, it's going to be VF divided by the time. And so that is going to be 5 meters per second divided by 0.10 seconds. So that's 50 meters per second. Right, so there's my A.
Good morning. Please pardon the interruption. Students who are taking the AccuPlacer test, Session B, students who are taking the AccuPlacer test, Session B, B, please report to the cafeteria at this time. Thank you.
So now that we have the A, now we can get the alpha because we have a formula. I'll go back to step 2, which to get the appropriate equation. A equals R alpha. So A equals R alpha, and we want alpha. So alpha is going to be A divided by R. And so step 4, alpha, the A is 50 meters per second. I'm sorry, 50 meters per second squared. Let me put that in there. I don't have the right unit. So meter per second is meter per second squared. So that's going to be 50 meters per second squared divided by R. So what is the R in this problem? No? No. Look, if this is my pivot point here, this is the arm's going to move like this. So that's the center of my circle. This is where the dart is leaving, right there. So it's what? 0.28. So 0.28 meters. That is your alpha. So that would be, if you solve that, what do you get for alpha? Right, 179 radians per second squared. Remember, when I write a meter, it's really like that's what a radian is for this size circle. So the meters would cancel out, and that's where the radian comes from. So now that I have the alpha, if I look at my equation, I know the alpha, I know the I, and I know the L, and the first force perpendicular is the M, which is the unknown. So I'm now just going to rewrite this equation to solve for the muscle's force. So I'm going to get, let's see, I'll use a different color here. So now I'm going back to step 2, and my equation with the numbers is going to be M times L equals I times alpha. And since I want the muscle, so it's going to be I alpha divided by L. And that's going to give me the force from the muscle. And so the I, let me go back here and read it, the I is 0.065. So this is going to be 0.065 kilogram meters squared. And the alpha is 179 radians per second squared. And that's going to be divided by, what's the L in this problem? What is it? 0.025. So in this problem, this is the R, that's the L. So this is the distance to the pivot point where the force is applied, and that's the R when I'm trying to convert a tangential acceleration into an angular acceleration. So 0.025. So whatever the top number is, multiplying that by 40, and what do you get? 465?